All right, hi everybody. We're going to be implementing Pong in this video. Nothing super complicated. We're going to be using Raylib, C, and yeah, I hope you enjoy. All right, this is going to be our starting point for the project. This is just a little template I made. All it really has is like a CMake file, a setup, which basically initializes Raylib as like a submodule, and then it lets you build. So if we go to the actual code, you start with something like this. I added min and max just for convenience sake, but this is basically what you get. And then basically what you do is you cd into build right here, and then we'll make it a little bit bigger just for convenience sake. And then you just do CMake that with a dot dot, and then you do build dot, and then I just like parallel, and then it builds. I've already built it just because, and then it's been project, and boom, we have Raylib up and running. The actual, if you're like, I don't want the executable name to be project or whatever, you can just change it right here in the CMake file. But we're going to be implementing Raylib. So I'm going to basically break this down into steps. And the first step is basically going to be, we're going to be implementing the game state. And so what I mean by the game state, I mean is these are going to be the data structures that we're going to be using to actually make everything run. So then we're going to have this. This is going to be the game, running the game. And then we'll have this. And then this is going to be a little bit long, so we do this. And then this is going to be our update, right? And this is going to be, if I could, there we go. And this is going to be our render. So what we're going to do is we're going to implement first our game state, then we're going to render our game state, and then we're going to implement the update. So 3 phases to implementing Pong, and then of course we should actually update our title, Pong. So I'm going to update this first, and I'm going to make it 1080 by 720, so it's a little bit bigger of a play space we're working with. And I'm also going to add this thing. I actually want to change this too, just because for me, I like this kind of thing. Screen height. This is my preference. And then the play start height is going to be like 50. And basically the reason why we're going to have that is if you can imagine like this area, let me do it like this. This area is our screen for just a second. Usually you're going to have text up here. So like it could be score, and then we could have like Pong, and then we'll have like another score, right? We don't actually want the ball to like be in this text area of the screen. So we're going to actually restrict where the ball can go by using this play start height variable. So once we have that, and I guess in all reality we can just put it in here, and then we have even clearer comments. So the first thing that we're going to have is we're going to have this thing called bool paused is equal to false. And all this is basically doing is we're going to have something in our update loop where it's basically like, and we'll just put it if not paused, update the game state, right? Otherwise, we're not going to do anything. We'll just render and keep going. But the next thing we're going to do is we're going to have our scores. So this is going to be player left score is equal to 0, int player right score is equal to 0, right? And so this is basically, we're going to be rendering the scores of everybody. Oh, this didn't update. Oops. And then we'll fix this too while we're thinking of it. If I could type, there we go. So now we're initting our window with the correct screen and width and height. And so this is basically where we have our player left score and our player right score. So this is basically how people are doing. And then what we now need to do is there are 3 like things or elements that go in the Pong game, right? There's the left side paddle, there's the right side paddle, and then there's the ball. So let's start with the player left paddle, right? And I'm really off on typing today, but that is okay. We're going to use a rectangle. And that just comes in Raylib, and we get .x is equal to, and I'll fill this in a second, equal to 0. Dot width is equal to 0, and then we'll do dot height is equal to 0. And then I'll correctly type that, add the semicolon, and then we'll get nice formatting. Okay, so this is basically where the player left paddle is. It's rendering it on the screen. And we're gonna basically, right here, when we init the thing, the window that is, we could like set config flags, and then I think there's like, let's actually see. If we go into like the definition, right, there are different flags that we can go to, and these are the different flags. So for example, I don't really, actually, can I get the configuration flags like more? Yeah, there it is. So like flag full screen mode, and then we can also set whether or not it's going to be like resizable. So in this, it's like resizable, which if we set it, then they'll be able to resize it. We're not going to set resizable because basically if we do that, we have to handle that kind of behavior. And since we're just focused on Pong, we're not going to bother with it. So this is our player left paddle. We need to now implement this for the right paddle. And you'll notice I haven't filled in any of the data points yet, which is okay. So we have our left paddle, we have our right paddle. And then what we also need to do is handle the ball that we're actually going to be moving around. So we have our ball position is equal to, and it's a vector, so we're going to have .x is equal to, and this one we just know, so we're actually going to implement it, screen width, and then .y is equal to 0.5 times screen height. And then we'll do this, and that's our ball position. The next thing to handle is the velocity of the ball. Because, right, this, unlike the paddles, in the case of the ball, we're actually going to implement some very simple physics. So what I personally like for Pong, I don't like when the ball starts off at an angle. So I'm just going to set it to 4f, and we can always play with it later. It's actually not a bad case of adjust.h. But we're going to just do this for right now, where the ball is immediately going this way, and it's, well, actually like when it goes to the left. So when we open it up, it's going to go this way. Okay. Yeah. Okay, so now we have this spawning directly in the middle. Actually, it's not directly in the middle. We could make it a little bit smarter. Should we? Because technically the height is slightly off center if we take into account the play start height, but I think I'm okay with it. Okay, so now let's handle this part right here. So I'm going to say this is 0.05, so 5% times the screen. Actually, this is totally wrong. So this is going to be, no, this is actually right, screen width. So it's going to be, this is where the end of the screen is. We're going to be 5% out of the screen width. Now, where is y going to be? We're just going to spawn it at 0.45 f, let me add f, times screen height. And so this is basically putting us somewhere in the middle. And then what we need to add is our width. So I'm going to make it like 0.02 times screen width. And this is something we'll play with in a little bit. And then the height, I'm going to make it 0.15. Yeah, 0.15 f times this screen height. So basically this is saying the width is 2% of how wide our screen is, and the height is 15% of it. So we can just take this and do this. And then this one right here, we will basically set it to be the opposite of it. So this is going to be 0.95 f times screen width. So it's going to be 5% over here. I don't know if that was in screen, but 5%, this is the edge. It's going to be 5% over here now. And then this one will actually be exactly the same. So we'll just copy and paste that. And yeah, that is actually all we need for our game state. Fun fact. All right, so the next up is rendering. So I'm going to change, first of all, I personally just like a darker background when I'm making games personally. And so basically what we're going to do is we're going to just start by, let me actually make these like 4, and this will be 2. We're gonna break this down into like little subproblems. First, we're gonna render the game, right? So that should be pretty simple. Then what we're gonna do is we're gonna render the header, and then what we're gonna do, render pause if necessary. So let's just start with the basics. First, we're just going to be rendering these paddles and the ball. So we can do draw rectangle, rec, and we can just pass in paddle, player left paddle, right? And then we'll just make it white. This next one is going to just be player right paddle. And then this last one is we're going to do draw a circle. And I think we're about to see that I forgot to do one thing. Because when I do this, I'm going to have the ball position, but you're going to see that what I'm missing is the radius. So let's do that. Ball radius, and then we'll just make it 0. We'll just start with like 20, and we'll just play around with it when we get to it. Because again, we know this is fixed size, so we can actually be a little bit kind of lazy, to be totally frank. But I don't like it. I don't like it. I thought I liked it, but I don't. Let's just do ball height, because that's less. There's screen height, and let's just do like times 0.1 f. And we'll just see like where that gets us. So we're in here. Now we need ball radius, and then this will also just be white. So let's see what this looks like now that there's actually something theoretically to look at. And you can see we have like unused variables, which is expected and okay. So we run it, and we can see the ball is way too big, first of all. And second of all, I think the paddles are a little bit off. So if anybody remembers adjust.h, this would be like a good candidate to actually use it, but we don't need to do it. So let's do 0.05. And then for this one right here, let's make it 1. Let's make this 1, 2. Let's make this 0.2. Let's make this 0.2, and let's make this 0.0. And then let's remake it and see what it looks like. So that to me looks a little bit better. This ball is still way too big, to be totally frank. So let's fix that to make it like, let's play around with like 2% of the width of the height. That's looking better. Frankly, I would think this will be even better, and then we should be good just to keep going. And that to me looks about right. We may end up, after playing the game, decide like maybe these should be a little bit shorter, but for now that looks fine to me. Oh, actually, since we're already looking at it, the next thing we're going to do is we're going to start displaying the scores and the header. So let's get to that next, our header. So let's start by drawing the line. So this is our line, right? And what we're going to do is we're going to have our start position X is going to be 0. Our start position Y is going to be our play start height. Our start end position X is going to be screen width. Our end position Y is going to be the exact same thing because it's going to be horizontal. I almost said vertical. And we're just going to make it white again. So if we do this, we can kind of get an idea of what we're looking at now. So now you can see we have this line that's going across the screen, and when the ball comes into contact with this, it shouldn't actually go past it. But now we can actually have space where we can render the title and the scores. So let's do that next. So I'm going to start with the middle. So we know the game's title is Pong, right? And then what we want to do next is we want to do our font size. So I'm going to start with font size is equal to 40. And if it doesn't work, then we can totally change it. So we'll make this to be screen height. And if we really want to do this, const char star title is equal to Pong, right? And then we can do const int title width is equal to measure text, and then we can pass in title and then font size, right? And then we can go even further because this is, if I'm not mistaken, let me do this. We're going to get our X position. So we're going to do screen width minus our title width divide by 2. Our height, we'll just make it 20. And if it looks bad, we'll fix it and we'll pass in white. And what am I missing? I'm missing too few arguments. So, and I'm missing font size. So that looks like it could look good, or else it could look kind of bad. So I would say our font size is a little bit big. So let's back that up to 30 and let's look at it again. And now that's looking about right to me. I want to change this position though to be like 17, I want to say. And now we have what I think is a good looking Pong right there. And next thing to do is actually to render the scores. So to do that, we need char buffer, and I'm just gonna make the assertion, or it's not, yeah, no, it's char buffer. I'm gonna make the assertion that we're never gonna have a score greater than 1,000. Now, if a score does go past 1,000, there will be a bug, but because this is just like a toy implementation of Pong, I think we're gonna be totally okay. So basically the way we need to do this, s_printf, right? And then we're going to pass in our buffer, and all this is going to take is a %d and like player left score, right? And then what we can do is we can do draw text, right? And then we can do buffer, and we're going to do like 0.1 times screen width, and then the position y is going to be 17. The font size is going to be font size, and then the color is going to be white. And because we're using 17 so much, what I'm going to add is const int header y is equal to 17. And then we'll update this so we have one less reoccurring magic number. Because I think it's kind of okay if it only happens once, but once you get to the point of it like happening a lot of times, then you kind of get to problems, I think, personally. And then this was giving an error because it expects an int and it's getting a float, so we'll just cast it to an int. So we're gonna look at this one real quick. Actually, we'll just do both, and if it looks bad, we can fix it. So we don't need this anymore. Instead of using the player left score, we're gonna use the player right score, and instead of using, and then we're gonna render it to the right side with 0.9. See make build, we look at it, and now you can see we have our scores updating. If we want to kind of see what happens if like we change the score of 1 to like 100, for example, then you can see we have that difference. And then what we can also do, because we're feeling like it, let's set it to 10,000 and just see what renders for fun. And you can see we get an exception because we're overflowing our buffer, which is expected, and that is okay with us, right? Ball radius, I guess, could be. Thank you for that error report. Okay, so now we're rendering the header, and now we want to handle one last thing before we move on to actually implementing Pong itself. We want to handle the case where the game is paused. So we have this right here, and because we're going to be reusing it, well, let's not. Actually, let's just use the paused fonts. No, I want to do this. Constant paused font size is equal to 40. I want it to be slightly bigger, to be totally fair. And then we're going to have const char star paused text is going to be equal to paused, pretty simple, const int pause width is going to be equal to, and we're going to measure the text, and we're going to pass in pause text, and then we're going to pass in the pause text font size. So far so good. And then what we can do is we can figure out where we're going to actually be rendering pause, like where we're going to start it in terms of the x coordinate. So const int, I'm going to name this px just because we're starting to get pretty far out there. And this is going to be screen width. And then it's going to be, I think it's going to be minus the pause. Well, yeah, it's 100% going to be minus. Why am I even acting like I don't know? There. And then there's p of x. So pause width, that's where we start. Yeah, that looks good to me. And then what we're going to do first is we're just going to draw text. And then the text is going to look like, we don't need to do quotations there, sorry, pause text. And then we have p of x, and then our p of y will be screen height divided by 2. This isn't going to be perfect, by the way, because we're not measuring the height of the text, but that is okay. The font size is paused font size. And then the last thing is right now we're going to make this white. And there's going to be a problem with this when we do it, where basically, oh, it's not paused. So let's update that real quick to true. Now we can make it, we can run it. And you can see there's this problem where if the ball stops around where the paused is, then it's going to look kind of bad. And you can also see like this is slightly off center. And we could fix it by measuring the y coordinate as well. Or what we could do is be a little bit lazy, -10 it, and then it should look just okay. Let's do like a -20. Okay, but this gives us this kind of problem. Yeah, this gives us this kind of problem basically where like, sorry, I keep going back in my head on whether -20 is right, and it's totally fine. But what we need to do basically is fix it so that the paused actually looks okay when there's a ball where the paused is. So I'm going to change the font color to black. And then what I'm going to do is I'm going to add a rectangle. Draw a rectangle, and I just want this. Is that what I want? We'll do a draw rectangle rec. Right, and it's going to take in a rectangle. Const rectangle rec, and we'll just do rec, and then it's going to take in a black. And then we're going to define our rec to pass into the argument. So dot x is going to be equal to px. Dot y is going to be based off of this. So we're just going to start with screen height. Divide by 2 -20. And we'll fix this when we get to it. And then, yes. So basically, let's actually just make the mistake, and then we can fix it when we get to it. So we have our pause width. So pause width, and I'm actually going to remove this -20. No, I'm going to keep it because it's what we have. And then we have our dot height, and that is going to be equal to, let's go 40, and we can adjust it when we need to. So let's see what happens when we do this. And you can see we ran into what I honestly did not expect. So let's make this like red just for extra clarity. Okay, so basically what you can see here is, yeah, oh yeah, that was silly of me. This should be white. There we go. And now everything will be hunky-dory. So basically what you can see here is the rec technically is fitting paused pretty like too perfectly. So basically we want the rectangle to be slightly bigger actually than the text. And so we can fix that. So rather than just p.x, we're going to do -10. And rather than the exact width, we're going to do +20 because we're going to count for the 10, and then we're going to go 10 pixels past. So let's look at what this looks like now. And that to me is looking decent. I want to actually make this a little bit bigger though. So I'm going to make this -30, and I'm going to make this 50 instead for the height. And now if we look at it, this is looking pretty decent. Let's make this 60 though. And that to me looks like a good paused. And all right, so now let's get to actually updating the game state. So we're going to start with paused. So if is key pressed, key P, super simple. Do this, paused is equal to not paused. So if we make this, oh, I'm not in build right now. Yeah, bin there. I press P, we change our state. Nothing's happening yet, but you can see paused is theoretically working. So now what we want to do is we actually want to update the game state. So the first thing to do is handle key presses. Key presses from players. Then what we're going to do is we're going to handle collisions. Then what we're going to do is we're going to handle the case where the ball goes off the screen to the left or right, and then scoring. So let's do this first. So if we're going to do is key down, and that basically means like if you hold, for example, let's do key W first, then the paddle for the left player is just going to keep going up. So how do we actually do that? And basically what we're going to do is we're going to actually add one thing, const float paddle mod is equal to 10.0 10f. And then what we're going to do is we're going to do player paddle left, right? Because we're going to be modifying the left paddle when we're using key W. And then it's going to be, so this is going to be sending us upwards. And so it's always counterintuitive, but up is going to be negative. So that's going to take us to this variable all the way up here, which is this. And so this is the minimum value that we can accept. So really what we're going to do is we're going to use that max macro, which we defined all the way at the start. Or we didn't define, I just had it here when we got here. So the way we can do this is the max value or our minimum value is going to be like play start height. And then the minimum is just going to be the player left paddle. And I messed this up, but that's okay. We paddle, oops, mod. So we'll fix this in a second. It's .y, and then this should be paddle mod. And so now what you can see basically is if this is the max, it's going to be this player paddle left height. And otherwise, we're going to just do -10. So let's see if this worked before we actually keep going. So we do this. You can see we still have unused things. Unpause. And now you can see I can't get any higher than this. Let's also change it so we're not starting in true paused, because that's no good. So we have this working. Now what we're going to do is the next case. If is key down, and then we're just going to do key S. And then the logic is going to be very similar, but instead of going up, we're going down now. So player paddle.y is equal to min this time. And then question is, of course, what's it going to be? And basically it's going to be screen height minus player, and we're just going to assume that there's maybe down the line we want to add extensions where like paddle heights can be different. So this is our minimum, because the way this is rendering is our paddle is here and then the height renders down on the screen. So there's that. And then the other case is it is paddle left. If I could type player left paddle .y minus paddle mod. And basically what you can see here is now this should theoretically work. So I'm going to hold S, and you can see I messed up because I did minus again when it should be plus. So now if I do it, I'm holding S, and you can see it stops when we get to the edge. So this is the behavior we want. Now let's implement it for the other paddle. If is key down, and then it's just key up, right? And then we're just going to take this and put it in here. And then instead of using the player right, we're going to use player right. And then same thing here, right? And then we're just going to take this. We'll also just do that. And then we'll do key down. Fix this for in a second. Player right. So now if we make it theoretically, when I hold the arrow keys, I go down, I stop, I go up, I stop. So that's looking good. So what's the next thing to do? We have this updating. Now what we want to do is actually we want to update the ball position. So the ball position, we're just going to do it super quickly, where we're just going to plus equal ball velocity dot x ball position dot y times equals ball velocity dot y. And then typically what you would see is this implementation of like a delta time. And then I think in Raylib you can just do times get delta time. Get mouse delta, no. Let's actually just let's do this. Raylib cheat sheet. We love Raylib cheat sheet. Delta time, and it is get frame time. So we'll go back into here, and then what we'll have in here is we can actually just get it when we need it. So this will be const float dt is equal to get frame time. And then we multiply it by dt. And I think when we do this, that -4 speed that we initialized a while ago is going to be, so yeah. I don't know if you noticed where the ball went, but it is all the way up here, which is no good. So this shouldn't be this, by the way. This should be plus equals. That makes way more sense. And you can see that it's just way too slow when we're actually multiplying it by delta time. So we can fix that. We'll just like 16, let's just say. And that's still too slow, so let's go to like 30. So it's going double what it was. And still pretty slow, but we can just go one more time. And I think this will be about what we want. Nope, still wrong, sorry. Go to -120. All right, and that's looking a little bit better. I'm actually gonna up it one more time though. Not, that is way too upped. Now if we look at it, that's looking better. Okay, cool. So now we're multiplying by delta time. And now what we're gonna do is we're actually gonna be handling collisions. So the specific collisions that we're going to be handling are when it collides with the top or the bottom, and when it collides with the like paddles of the player. So what we're gonna do is we're going to have two cases. So there's going to be the ball velocity dot x is less than 0. Otherwise, we're going to have this other case, which we're not actually going to implement yet. But basically, if the ball velocity dot x is negative, that means it's going to the left side. Otherwise, we're going to the right side. So what we're going to do is Raylib has this handy function that we can use. Check circle collision, check collision, circle rec, there it is. And so what we can do is we can say this is the ball position, this is the ball radius, and then this is the player left paddle. So we're checking for a collision, and we can also just put this into while we're thinking about it, and this will be the player right. And so there we go on that. And now we have to do, unfortunately, a little math. So const float hit pause is going to be equal to ball position dot y minus the paddle player left paddle dot y. And then we need to divide it by the height. So player left paddle dot height. And so basically what this is doing is we have like our paddle, and it's telling us where along this paddle, percentage-wise between 0 and 1, it hit. And just to be like super safe, we're actually going to, we're not going to make this const. We're going to be a little bit like safe here, just in case I made any mistakes, and we're going to clamp it between 0 and 1, and it goes like this actually, sorry. Hit pause, 0, 1. And I think it's saying that we don't have clamp. Yeah, so we need to include that. And so basically now we're guaranteeing it's between 0 and 1, and I'm going to fix this to be like this. So it's guaranteed to be a float. There's no craziness that goes on. And then the next thing we want to do is we want to find out where the angle is. So what we're going to do is we're going to have const float a, we'll just call it for convenience sake, and we're going to go hit pause minus 0.5 f. So now what we're doing is we're taking it from a range of 0 and 1, and we're shifting it to the left, so it's between -0.5 and 0.5. And then what we're going to multiply it by is pi divided by 4. So that's just in radians, and then after that we can actually just do the rest. So this is going to be our speed, right? And so the way we're going to do that is we're going to do the vector length. So this is the magnitude of the ball velocity. And then what we're going to do is we're actually going to, on every single contact, we're going to make it so the ball goes slightly faster every single time it hits a player paddle. And then what we can do is we can just update the velocity. So velocity, ball velocity dot x is going to be equal to speed times cosine f, so just the cosine, and then we're going to pass in the angle. And then the velocity of y is going to be equal to speed times sine f a, and that's all it's going to be. So let's actually see if this worked, and if I didn't make any mistakes. And it's going to hit, and you can see it's going slightly down. Now, when we try to collide with this, nothing's going to happen. So let's fix that next. So all we have to do is copy and paste, and then we need to update some stuff. So this should be, for example, right. This should be right. And that's all good. And the only thing we have to change now to make this work is do pi minus. And that's basically because on this side we were reflecting out this way, and now since we're on the right side, we don't want the ball to go this way again. We want it to go to this side. So that's why we do pi minus, and we're in radians. So let's see if this works. I'm going to kind of try to make it a little bit more extreme, and you can see it went down. And I'm going to put this right here. Oh, we don't actually, oops. Let's try that again. I'm not going to move it this time. And I'm going to move this one just a little bit down, and we should reflect up. And you see like it's going to go through the play height, and it's not going to do anything when we get over here. So that's the next thing to handle. Because now we have collisions with the paddles. Now we need to handle collisions with walls. So I should have had collision with top and bottom wall. Okay, so what we're going to have is if ball velocity, oops, that was terrible typing, ball velocity dot y, and we're going to have is greater than 0, right? So that means we're starting with the case where it is going down on the screen. And what we're going to do is say if y is greater than or equal to screen height minus ball radius, then what we need to do is ball velocity dot y times equals -1. So we're reflecting it. And then what we're going to do is we're going to move the ball up so we don't risk it coming into contact with the screen again. And so ball position dot y is equal to screen height minus ball radius. So let's actually look at what happens here. So we're going down, so we're going to go all the way up here, and we do dot x is equal to 0.0f, and we're going to make this -300, and we're just going to see what happens. So you can see, I don't even know what carbon core is, to be totally frank. Let me remake it, run it, and now it should be going up, and you can see I messed up. Did I mess up? Oh no, it should be +300. There we go. Now we run it, and it's going to go down, and it's just going to reflect up. Now we don't have the case where it hits this area right here. So let's do that now. So we're going to make this -300, just so we're thinking. And then we're going to go all the way back down here, and we're going to add another else. And all this is going to be is we're actually just going to do pretty much the exact same thing, except if ball position, oops, dot y is less than or equal to play start height, plus ball radius, if I'm not crazy. Yeah. Right, then we're going to just take this, and then okay, sorry about that. That was my lovely dog. So we do times -1. And then what we need to do is we need to fix this to now be based on the play start radius. Start height plus the ball radius. I think I said play start radius, which is just an amalgamation of the two. So we collide going up, and now we'll see if we collide going down. And you can see we just get a nice little back and forth. So collisions are working, at least when we're going up and down. So now what we need to do is we need to handle this last thing, where what happens when the ball goes past either side of these edges. So if ball position dot x is less than 0, right? Or else if ball position dot x is greater than or equal, we'll just make it greater than screen width, right? So those are our two cases. And in the first case, we're going to do we'll do the player left paddle score. So this actually goes down here, and then we can just do plus plus. And then if we do, player right score, and then we can do player left score. And then what we need to do is we need to reset the ball. So the first thing to do is this needs this, ball velocity dot x is going to be equal to, and I think let's do negative 300f, right? And yeah, and then let's do ball position dot x is equal to 0.5 f times screen height. This should be screen width. Ball position dot y is equal to 0.5 f times screen height. And I think that is all we need, but we'll see in just a second. So, and then we'll just change this to be positive. So let's CMake it, let's run it, and you can see I didn't update that, so the balls are never actually going to go to where it needs to go. 3, 0, there. That looks good to me now. I'm not really sure why it's saying. Okay, let's just see what happens. What's going on? Oh, so I just have it's like this. And then did I update the y position, the y velocity? Because that would be something I should fix. Yes, I should fix that. Ball velocity dot y is equal to 0 f. And then I also want that there. Velocity dot y is equal to 0 f. Okay, cool. So now nothing's happening. And that's because this right here, no, this is negative 300. This is y. Do I need to CMake it and run it again? There we go. So we have a game of Pong going. I'm going to go like this, and we're going to see if 1 pops up here, and you can see 1 popped up there, and then it switched, so the ball went over there. So now I'm going to score with the left paddle, and we're going to see what happens. And you can see the score updated, and now this person gets the ball. And that's Pong. It's working exactly how we want it to. We have like stronger angles if we come to the side. And yeah, that's really all it took. This is Pong. Pretty fun game, I think. How many lines did it take us to do? So 220 lines-ish with what I hope is pretty clean code and pretty easy to follow. If anybody's curious, we're going to be using this kind of Pong code in the future, so that's why we're doing it. We're actually going to be making a couple more simple games, and then we're going to be using all those games to show off something else in a future video, assuming I get to it. But yeah, I hope everybody really enjoyed this one. I certainly enjoyed making Pong. I've made it a bunch of times, but every time I feel like I implement it a little better and a little better. So hopefully you all enjoyed this one as well. And yeah, I'll see you in the next video. Thank you so much. Bye.